All right, so now we're ready to step into hypothesis testing for the chi-square test. And this should look pretty familiar at this point. So the first thing we do, as always, is create our hypotheses, which is just pi1 equal to pi2 out to pi c, where c is bigger than or equal to 2, and it's the number of groups that we're analyzing. And h naught false is our alternative hypothesis, meaning there's at least one pair of proportions that are different from one another. Of course, that doesn't mean all of them, and we don't know which ones. Step 2, we just want to select our significance level and our sample sizes, so n1 out to nc for the number of groups we are looking at. And then we calculate our test statistic, which in this case is chi-square, and we just did this in the last video. It's the sum of our observed and expected counts squared divided by our expected count. And then we can move on to the critical value approach or use the p-value approach. So in this case, we can compare our chi-square stat to, so this is going to be from a chi-square distribution with c minus 1 degrees of freedom and alpha level of significance. So c minus 1 degrees of freedom, so that's the number of groups minus 1. That has its own table, but we'll just use Excel for that, just like we did in the last chapter. And then we could calculate the p-value, which is just the probability of a chi-squared with c minus 1 degrees of freedom exceeding our calculated test statistic. And then our rules are still the same as they've been since chapter 9, which is that we're going to reject the null hypothesis and accept the alternative if our test statistic exceeds the critical value or if the p-value is less than or equal to alpha. Otherwise, we're going to fail to reject h naught. And of course, we should always provide an interpretation. And that's how we're going to do our hypothesis testing. So, of course, let's return to our example. So let's go ahead and do this. And we've already done most of the heavy lifting. So let's start with our hypotheses. So that is that the proportion of those who would choose this hotel again for each of these 3 hotels would be the same. So I'm going to say pi, so I'll say GP for Golden Palm is equal to pi PR for Palm Royale, which is equal to pi PP for Palm Princess. And the alternative is that H naught is false. So the second step, let's just go ahead and use alpha equals 0.05. And here we had n was equal to 700. N1, so Golden Palm was 216. N2, Palm Royale, we had 232. And N3, Palm Princess, 252. The third step was our test statistic, right? Test statistic, our chi-squared statistic. So chi-squared stat. And we did that up above, and we got a value of 40.23. So just to remind you, it was this calculation. We had already found all of our expected counts, and we calculated 40.23 for the chi-square statistic. Okay, step 4. So if we were to do the critical value approach, so this would be chi-squared stat is bigger than chi-square with c minus 1 degrees of freedom. So maybe I'll write that up here. C was equal to 3, right? We had 3 hotels, Golden Palm, Palm Royale, Palm Princess, that's 3. So C minus 1 would be 2. So this is going to be 2 degrees of freedom. I'll just write C minus 1 is 3 minus 1 equal to 2 degrees of freedom. 0.05. And if we look that up in our table, or this is going to be in our Excel lab, so I'll show you how to get this number. It is 5.99. move this down here. Make that a little more legible. And then if we wanted to do the p-value approach, it would be p-value is equal to the probability chi-squared, 2 degrees of freedom, bigger than chi-squared stat. So that would be the probability of chi-squared, 2 degrees of freedom, bigger than what we calculated, which is 40.23. And I'll just let you know it is very, very small. It's actually less than 0.001, so I'll just leave it there. Okay, so now let's do our conclusion. So let's first start with our critical value approach. So chi-squared stat is equal to 40.23, which is bigger than 5.99, which is our chi-squared. And I forgot to write, this is our rejection region. So sorry, I forgot to write this up here. Rejection region is equal to 5.99. And so this is true, 40 is bigger than 5.9, and therefore it's in our rejection region. So we reject H naught and accept HA. If we wanted the p-value approach, so our p-value is equal to 0.001, which indeed is less than 0.05, which is our alpha. And therefore, we would reject H naught, accept HA. And then finally, let's just give an interpretation. So we rejected the null hypothesis. So we would say there is enough evidence to conclude that the proportion of customers that would choose the hotel again is not the same across the 3 hotels at the alpha equals 0.05 level of significance. Okay, and we're done. We determined that these are not the same, these proportion of people who would return again. So the next step would be to determine which one actually is the highest. We're not going to do that in this class, though. We're actually going to move on to the chi-square test for independence next.